According to the National Electrical Code, specifically Article 450.13b, the area above a suspended ceiling is generally not considered a permanently enclosed hollow space. This is crucial for understanding transformer installation requirements in such locations. Let's break down what this means for electrical contractors. Article 450.13 addresses the accessibility of transformers, particularly those installed at hollow spaces. A hollow space, in this context, refers to areas that are not permanently closed in by the building structure. This distinction is important because the code imposes specific conditions for transformer installations within these spaces. These conditions typically include ensuring adequate ventilation, maintaining accessibility for inspection and maintenance, and in some cases, providing a fire-resistant barrier. The reason the area above a suspended ceiling is typically not considered a permanently enclosed hollow space is that suspended ceilings are designed to be readily removable. This allows access for maintenance, repairs, and modifications to the building's infrastructure, including electrical, mechanical, and plumbing systems. A permanently enclosed space, on the other hand, would be one that is structurally sealed and not easily accessible without significant demolition or construction work. The NEC distinction between these types of spaces directly impacts the requirements for transformer installations. If the space were deemed permanently enclosed, the installation might be subject to stricter regulations, potentially requiring specific types of transformers or additional safety measures. Since the area above a suspended ceiling is generally accessible, the code allows for more flexibility, provided that certain conditions are met. One of the primary requirements is adequate ventilation. Transformers generate heat during operation, and this heat must be dissipated to prevent overheating and potential equipment failure or fire hazard. The NEC mandates that transformers installed in hollow spaces have sufficient ventilation to ensure that their operating temperature remains within acceptable limits. This can be achieved through natural ventilation, such as openings to the surrounding environment, or through mechanical ventilation systems, such as fans or air conditioning. The specific ventilation requirements will depend on the transformer size, design, and operating characteristics. Another critical requirement is accessibility. The NEC requires that transformers be accessible for inspection, maintenance, and repair. This means that electrical contractors must be able to reach the transformer easily without having to remove or dismantle significant portions of the building structure. In the case of suspended ceilings, this typically means that the transformer must be located in a manner that allows access through removable ceiling tiles or panels. The code may also specify minimum clearances around the transformer to facilitate safe and effective maintenance work. In addition to ventilation and accessibility, the NEC may require a fire-resistant barrier in certain situations. A fire-resistant barrier is a physical barrier designed to prevent or delay the spread of fire. This requirement is particularly relevant in buildings with specific fire safety requirements, such as those with high occupancy or critical operations. The type and rating of the fire-resistant barrier will depend on the building's construction and the specific hazards associated with the transformer installation. It's important to consult with local building codes and fire safety regulations to determine the specific requirements for fire-resistant barriers in your area. When installing a transformer above a suspended ceiling, there are several practical considerations to keep in mind. Firstly, it's essential to ensure that the suspended ceiling system is capable of supporting the weight of the transformer. Suspended ceilings are typically designed to support light fixtures and other lightweight equipment, but they may not be able to handle the weight of a large transformer. Reinforcement or structural modifications may be necessary to ensure that the ceiling can safely support the load. Secondly, it's crucial to coordinate the transformer installation with other building systems. The area above a suspended ceiling is often crowded with electrical wiring, plumbing pipes, and HVAC ducts. Careful planning and coordination are essential to avoid conflicts and ensure that the transformer can be installed safely and effectively. Thirdly, it's important to consider the environmental conditions in the area above the suspended ceiling. This space may be subject to temperature fluctuations, humidity, and dust accumulation. The transformer should be selected and installed in a manner that protects it from these environmental factors. This may involve using a transformer with a suitable enclosure rating or providing additional protection such as a dust cover or a humidity control system. Finally, it's essential to comply with all applicable codes and regulations. Electrical codes, building codes, and fire safety regulations all play a role in governing transformer installations. It's the responsibility of the electrical contractor to be familiar with these codes and regulations and to ensure that the installation meets all requirements. This may involve obtaining permits, submitting plans for review, and undergoing inspections. The NEC is a comprehensive set of guidelines for safe electrical installations, but it is not a substitute for sound engineering judgment and professional expertise. Electrical contractors should always consult with qualified engineers and other experts to ensure that their installations are safe, reliable, and compliant with all applicable codes and regulations. The specific requirements for transformer installations can vary depending on the jurisdiction. Local amendments to the NEC or other local regulations may impose additional requirements or restrictions. It's essential to be aware of these local requirements and to comply with them. Proper ventilation is critical to the safe and reliable operation of transformers. Insufficient ventilation can lead to overheating, which can damage the transformer and create a fire hazard. The NEC provides detailed guidelines for calculating ventilation requirements based on the transformer's size and operating characteristics. These guidelines should be followed carefully to ensure that the transformer has adequate ventilation. Accessibility is also essential for routine maintenance and repairs. Transformers require periodic inspection and maintenance to ensure that they are operating properly. This may involve checking the oil level, inspecting the windings, and tightening connections. If the transformer is not easily accessible, these tasks can be difficult or impossible to perform, which can lead to deferred maintenance and potential equipment failures. The NEC requires that transformers be accessible without requiring the removal of permanent building structures. This means that the transformer must be located in a manner that allows easy access for maintenance personnel. Fire-resistant barriers are designed to protect against the spread of fire. In the event of a fire-resistant barrier can help to contain the fire and prevent it from spreading to other areas of the building. The NEC may require fire-resistant barriers for transformer installations in certain locations, such as buildings with high occupancy or critical operations. The type and rating of the fire-resistant barrier will depend on the specific hazards associated with the transformer installation. Transformers are available in a variety of sizes and configurations. The size of the transformer will depend on the load it is intended to serve. The configuration of the transformer will depend on the voltage and current requirements of the load. It's important to select the correct size and configuration of transformer for the application. Overloading a transformer can cause it to overheat and fail. Using the wrong configuration of transformer can damage the equipment it is serving. Transformers are typically installed by qualified electricians. Electrical work can be dangerous, and it's important to have the necessary training and experience to perform the work safely. Qualified electricians are familiar with the NEC and other applicable codes and regulations. They can ensure that the transformer is installed safely and correctly. Regular maintenance is essential to ensure the safe and reliable operation of transformers. Transformers should be inspected periodically for signs of damage or wear. Connections should be tightened, and the oil level should be checked. Any necessary repairs should be performed promptly. Proper maintenance can help to extend the life of the transformer and prevent costly failures. Transformers play a vital role in electrical power distribution systems. They are used to step up or step down voltage levels to match the requirements of different equipment and loads. Understanding the principles of transformer operation and the applicable codes and regulations is essential for electrical contractors and other professionals involved in electrical installations. Specifically, understanding the applications for NEC Article 450.13b is critical when deciding to install a transformer. So to reiterate, the area above a suspended ceiling is not a permanently enclosed hollow space, so long as the conditions of ventilation and fire-resistant barriers are met.